Hello and welcome to another video tutorial. In this video tutorial we'll be going through the wave velocity worksheet, where this equation forms a really big, really important part of your work. It's the wave speed equation, which is used in lots of different levels of physics and is really universal to waves. So V, which is wave velocity or wave speed, is equal to F, which we've seen before, which is frequency, times by this Greek letter here, lambda, which some people think of or refer to as an upside down Y, and that's essentially the wavelength. Now you don't have to know it in terms of symbols. I will end up using symbols and words in different places, but it may help you just to kind of break that down a little bit, thinking of this as V equals F lambda, or it's completely fine to do wave speed or wave velocity equals frequency times by wavelength, but that triangle will be really useful throughout this worksheet. You had a worked example here which is highlighted in blue, and a video as well that you can watch on the wave equation, which is in the link, and we'll start off by going through question 1 and onwards, so over to question 7. And as with all of the video tutorials, you can pause, rewind, check your answers, correct anything that needs correcting, and just really try and follow it to get an understanding of how these questions can be worked out, especially if there were one or two that you got a bit stuck on. So number 1, calculate the speed of a wave with frequency of 10 kHz and a wavelength of 2 meters. So the K, as you can see in this worked example, is for kilo. So what that means is we've got 10 kilohertz or kilohertz, which is essentially then times by 1,000. So we start off with the fact that frequency is 10 kilohertz, but this is actually times by 1,000, which is 10,000 hertz. You've got to make that unit conversion before we do anything else. You'll notice here that wave velocity should always be in meters per second before it goes into your calculation, frequency in hertz, which it is now, and wavelength in meters, which for question 1 it is already in meters. So that's a pretty good start. So our next line, because we're trying to work out the speed or the wave velocity, I'm just going to put here V equals F times wavelength, just to keep it a little bit more simple, rather than trying to each time do this where you go to insert and then your special character and you try and put in your lambda from there, which you could do, but it will just be easier for us for this video, just put times by wavelength. So that's good so far. So we know that the wave velocity is going to be 10,000, because that's 10,000 hertz, our frequency, times by a wavelength, which is 2 meters, which gives us a final answer where the wave velocity is 20,000, and it's 20,000 meters per second. So again, just going back to those units, m/s, meters per second for your wave velocity. What I'll do, as I have done in previous videos, is I'll just keep answers highlighted in green. Should make it a little bit more kind of stand out, a little bit more, make it a bit easier to see those answers as they pop up. Remember, obviously you can check your video, you can pause this, rewind it, however you want to. Calculate the speed of a wave with a wavelength 50 centimeters and a frequency of 4 kilohertz. So we think back to our units. Have we got okay, well, we're looking for wave velocity, so we don't need to worry about units for that for now. Have we got frequency in hertz, and have we got wavelength in meters? Well, we look at this and we've got wavelength in centimeters. So first of all, we need to do 50 centimeters divided by 100, which is our wavelength. So we should really try and keep track of that. Wavelength is 50 centimeters divided by 100 to give us 0.5. So not 100, 10, 0.5 meters. And we've got frequency, which is 4 kilohertz, which, as we saw before, you times it by 1,000. So 4 times 1,000 gives you 4,000 hertz. So now we've done our conversion to frequency and wavelength. So we're now ready to go with our equation, which is V, wave velocity, equals frequency times by wavelength. And now we just substitute our numbers in. So V is going to be equal to 4,000 hertz times by 0.5 meters. Now I like using this trusty calculator, so 4,000 times by 0.5, we've got 2,000, so our final answer V equals 2,000, because everything is in standard units, meters per second. And that's something just to watch out for. Try and do the conversions before trying to use your equation. Calculate the frequency of a wave travelling at 500 meters per second with a wavelength of 25 meters. So wavelength should be in meters, it is in meters, so that's all good. Wave speed or wave velocity should be in meters per second, it is in meters per second, so that's good as well. So what's the catch in question 3? The catch is that we've got to work out the frequency. So we cover up the F, that's going to be our subject, so we're going to put here as part of our equation F equals something, and it's going to be leaving us with V over lambda, or wave velocity over wavelength. So just put here V over wavelength. We know that our units are all correct, they're all in the correct units. So all that we have to do here is 500 meters per second, which is our wave speed, divided by the 25 meter wavelength. 500 divided by 25, let's just bring up that calculator. 500 divided by 25, and we have an answer of 20. So F equals 20, and because everything is in standard units and we're looking at frequency, it must be in hertz or Hz. Okay, question number 4. Again, just having a look at these units. So we've already got wavelength in meters, so that's all good, but we've got 100 kilohertz. So let's put here frequency equals 100 kilohertz. We'll just do our calculation, conversion calculation. So we'll do 100 times by 1,000, just getting that into our hertz. If you want to, you can use the calculator. 100 times by 1,000, conversion into hertz. And just be careful with how many zeros there are. It looks like it's going to be 100,000. So 100,000 hertz. Now what can we do with that information? We want to work out the speed. So this is one that we haven't done yet. So if we cover up the V, what are we left with? We're left with frequency times wavelength. So just going to put our equation in, which is V equals frequency times by wavelength, or V, now we substitute 100,000 hertz times by the wavelength, which is 3,000 meters, and that looks like quite a lot, but let's just see what our answer comes out as. So 100,000 times 3,000. Let's count how many zeros there are. 1, 2, 3, 4, 5, 6, 7, 8 zeros after the 3. So we put 3, 0, 0, that's 2, 3, 4, 5, 6, 7, 8. And it's meters per second because our units are all standard units, hertz and meters. Now that's a really big number, 300 million meters per second, and that's the speed of any electromagnetic wave in a vacuum, otherwise known as the speed of light. You could write that in standard form if you wanted to, or sometimes your calculator might give you the answer in standard form with some of these large numbers, in which case I'll just put that into brackets, which is 3 times 10 to the 8 meters per second. If you want to use that as a power, just highlight it, and then it's control and the dot or the full stop. Okay, let me just highlight that, keep it in green as with all the others, just keep it standing out. And number 5, so calculate the speed of a wave with frequency 30 MHz and a wavelength of 10 meters. So MHz, you've got to think about what might MHz be. So we've already done K, or kilo, which is kilohertz, it's times it by 1,000. This time what we've got with 30 MHz is we're actually going to be timesing it by a million. So we'll just put here frequency equals 30 MHz, MHZ, that's mega, M for mega. And what we'll do then is we're just going to do 30 times by million, which is going to give you 30 million hertz. Again, you could put this in standard form and that would be completely fine. Again, we'll put in our equation, and this time I'm just going to cheat a little bit and take that equation from here because we're looking for the speed. So V equals F, or frequency, times by the wavelength. Just get that highlighted in green as well. And then what do we do with that piece of information? We go V, which is our wave velocity, is going to be equal to 30 million hertz times by 10 meters, which is our wavelength. And you'll see, perhaps, this will come to the same answer as before for question number 4. So 30, 123 again, times by our 10, and we've got 1, 2, 3, 4, 5, 6, 7, 8 zeros again, meaning our answer again is going to be 300 million meters per second. Again, you could put that into standard form like here, 3 times 10 to the 8. What was the significance of that number? See if you can remember. It's the speed of light, or the maximum speed that any EM wave will travel in a vacuum. Okay, calculate the wavelength of the wave traveling at 11 km per second with a frequency of 5.5 kilohertz. Now K, we came across here as kilohertz, so that must be kilometers, and so what we've got to watch out for this time is we'll put V equals 11 km per second, but that then means we've got to do 11 times by 1,000, because our wave velocity should always be meters per second, not kilometers per second. So do 11 times by 1,000 to give you 11,000 meters per second. So that's your speed, or your wave velocity. We've also got your frequency, which is 5.5 kilohertz, and we know from before that means we've got to do 5.5 times by 1,000, which is 5,500 hertz, and then we're going to try and work out the wavelength. Now, to work out the wavelength, that's this one here, the lambda. So if we cover up the lambda, we're left with V, wave velocity, divided by F, or frequency, so wave velocity divided by frequency. I'm going to put that in over here as wavelength equals wave velocity divided by frequency. In other words, if we now substitute our numbers in, then we get V, which is 11,000, divided by the frequency, which is 5,500, and we bring up the trusty calculator. So 11,000 divided by 5,500 gives us an answer of exactly 2, meaning our wavelength is equal to 2. Think about that here with the units. Wavelength in meters, so it's going to be 2 meters with that in our standard units. And you've made it so far to the final question, which is question number 7 for this video. Calculate the frequency of the wave below, which is travelling at 9 kilometers per second. So first things first, we write down that V is equal to 9 kilometers per second. We'll follow the format from up here, and that means kilometers, you've got to convert it, times it by 1,000, so 9 times 1,000, which is going to be equal to 9,000 meters per second. That's important because we're making sure that these are the units we're always working in. So that's all good, but now we've got to work out the wavelength, and that's a little bit more tricky this time. So the wavelength from this image, fortunately you don't have to try and measure it with your own ruler, use the one on here. The wavelength, remember, is going to be the distance from one point on a wave to the same point on the next wave. So go from this peak to peak distance, and you use the red lines and the ruler, which shows it's 12 to 15 and that's 12 to 15 centimeters, as you would have on a regular ruler in class. So if we did here 15 centimeters, take away the 12 centimeters, work out the difference, 3 centimeters. Again, that's good, but think back to this question here. We had centimeters, we had to convert it to meters, we divided by 10. So here we'll do I'm sorry, there's a problem there. That should say 100. Sorry for that oversight. The answer is correct, it's 0.5. Apologies, it should definitely be divided by 100 if you want to convert centimeters into meters. And that's just me testing you and seeing if you were going to pick up on the purposeful mistake in the video. That was 100% by design. So back to this one here. 3 centimeters divided by the 100 gives us 0. In fact, let's just do this on here. 3 divided by our 100, because it's definitely divided by 100 to get it to meters, 0.03 meters. So now we've got our wave speed or velocity and we've got our wavelength in meters. All that's left is to work out the frequency. So all we have to do is go back to our equation here. Frequency is wave velocity over wavelength. So frequency equals wave velocity divided by wavelength. In other words, frequency is going to be, when we substitute our numbers in, 9,000 meters per second divided by 0.03 meters. Try and work out our frequency, and our frequency answer comes out as 9,000 divided by 0.03, which is 3 with 5 zeros after it. So 3, 1, 2, 3, 4, 5. And just for ease, I'll put a comma in to see that a bit more clearly, and it's 300,000 hertz. So let me just highlight that one in green as well, and there ends the questions for this video. Remember to just check back. I'll scroll through this slowly, just from the top. Makes it a bit easier to just double check your answers as you end this video. And if you have any problems or questions, or there's anything you're not sure about, please message me and get in touch. Thanks.